Hello students, and welcome back to the video lecture series of software engineering. Today's topic is Introduction to Software Engineering, and I am your instructor, Ms. Shruti Rawal. So let us study the first thing in software engineering, and that is, what do you mean by software? Okay, so first thing that we need to study in software engineering is that what is exactly a software, and then we can shift towards the software engineering methodologies. Now, what do you mean by software? If someone asks you, you will say that software is like a program. It means it is a set of instructions. Yes, you are correct. Software is nothing but it is a set of instruction, but it is not limited to set of instruction. It is more than that. So let us study the definition of software in parts. The first thing that software is, it is a computer program which provides desired functions and features. Okay, so it means yes, it is a set of instruction which provides you the desired functions and features. So there is basically an aim in which you have list of functionalities and features which you want to accomplish, and for accomplishing that set of functionalities and features, the program that you write, that is known as a software, right? Now the next thing that software is, it is basically data structure. Now you might have studied data structure as a whole subject in your third semester, and you know what do you mean by data structure and what is the actual definition of data structure. Now why are we calling software as a data structure? Software basically is not data structure, but it consists majority of the data structure. And why is data structure used in software? Because data structure is a thing which helps to manipulate the information, right? You know that it is a mathematical and logical model which you use for manipulating the information. Now software consists of information, it consists of data. Now if you want to manipulate, if you want to structure that data, you will have to use data structure. So data structure is majority of the portion of software. So the first thing that software is, it is a program or set of instruction. The second thing the software is, it is data structure. And the third thing that software consists of is descriptive information. No software is fully completed without descriptive information. Now what sort of descriptive information are we including? The first is operation. It means what sort of operation is software performing. Now if you have any software, you know that you will have a user manual with it, that how to use that software. Also you will have a list of functionalities and features that you can use with that particular software. So descriptive information is the combination of all the operations that a software does and how to use that particular software, that is the user manual of the software, right? So the three things that software is, the first is set of instruction or program, the second thing is data structure, and the third thing is descriptive information. The combination of all of this is known as a software. Now let us proceed further to the software characteristic. Now we have heard these two terms, hardware and software, in our real life. Now what is the difference between hardware and software, and what are the different characteristics which distinguishes software from hardware, that you have to study in this topic. The first characteristic of software is, software is developed or engineered. It is not manufactured in the traditional sense. Now for understanding this characteristic, the first thing that you need to understand is, what is the difference between manufacturing and developing. Now manufacturing, if you study the definition of manufacturing, it is basically related to hardware and the factory in which the goods are produced, right? So manufacturing is something in which you have a predefined methodology and you are just recurrently using that methodology to produce goods, right? So that is manufacturing. But is software manufactured? No. Software is more than that. The whole process of software is different from manufacturing, in which you are having a process which is continuously changing. You are having a process which may be adapting. You are having a process which may not be recurrent, but it is adapting according to the real life scenarios. and you can say the relationship in manufacturing between the people and the manufacturer, and the relationship between the process in software development and people is totally different. So whenever you are referring to hardware which are manufactured in the factory, you are using the term manufacturing, whereas wherever you are referring to software, instead of manufacturing, the term that you are using is development, which is you can say prescribed process, an ever adaptive process that you use for engineering a software, right? The next characteristic of software is that although the industry, that is software industry, is moving towards component based development, most of the, or you can say majority of the software development is still custom built. Now all the methodologies that we are using currently in software industry, that we have been inspired from the hardware industry, and one of the methodology that we have taken directly from hardware industry is component based development. Now what do you mean by component based development? Component based development is very popular in hardware industry, wherein you have different components, you assemble those components and you have a final product, right? For example, if you want to develop or if you want to manufacture a table, you have some woods, you have steel, you have screws. So these are the components which you assemble according to a predefined architecture, and you recurrently use this architecture to manufacture the good, or you can say table, right? Now this is component based development for you in hardware industry. Now what is component based development for us in software industry? That is basically we have reusable templates which we are using in our software, and we are not writing the coding from scratch. Okay, for example, if you are using .NET framework, you know that the user interface, that is the GUI, you have drag and drop components, right? So you are not writing the coding for GUI from scratch. So that is one of the thing that you can say it is a component based development, in which you have different templates which you are using. Okay, now although you can see that in .NET you have GUI based components which you can reuse, but most of the code is custom built because the client is different. The requirement of every client is different. Although you are using a template, for example, if you are using WordPress or if you are using Bootstrap for designing, still you will customize the components according to the need of customer. And so even though software is using component based development, currently majority of the software is custom built. Now what are the advantages of component development? Basically the first advantage is that it is obviously having less cost than custom build, because you are not developing everything from scratch. You have reusable components which you are assembling and producing a software, so the cost is less. Because your human resources will be less, software resources will be less. Limited design, because you are reusing something, so there will be limited scope for customizing it. So you cannot fully target the customer's need by having limited design. This is one of the disadvantage of component based development, but it is quicker. Okay, you know that in custom based development you have to design, code everything from scratch in software, whereas if you are using component based development, you have something and you are just assembling that thing and producing a software, so it is very quicker. What are the advantages of custom based development in software? The first is customization according to the requirement of client. So client will be very pleased and amused to see how much customization you can accommodate in the software if you are following a custom based development. Built-in SEO, so majority of the custom based development have built-in search engine optimization. Also the major disadvantage of custom based development is it is having a longer development time or schedule, right? Because you are doing everything from scratch, so you will need more human resources. Also you will need a more detailed schedule and longer development time, right? So this was the characteristic of software. That is the second characteristic. The third characteristic of software is software doesn't wear out. Now what do you mean by wear out? You know that in hardware let us take an example of boots, right? So if you have fresh boots, they are not generally wearing out, but as time passes, due to the environmental melodies, you know that these boots get rusted, right? So what does it mean? They are wearing out, because hardware is something that is physical and it is affected by the external environment like weather. Whereas software is not a physical thing, it is a virtual thing. So software doesn't wear out. So this is a basic characteristic difference between software and hardware. Okay. Now let us move further and try to understand what are the different software application domain. Okay, it means what are the different types of software that you can create. The first type of software is system software. Now what do you mean by system software? System software are types of software that provide platforms for another software to execute. For example, Windows 10, that is an operating system, is an example of system software. Also you can say compilers, editors, etc. are different types of system software which provides platform for another software to run and execute, right? The next set of software, or you can say type of software, is application software. Now these are the real life software which have a business need, so that they are having you can say a sort of point of sale. They are having customized software functionalities, and there is a, you can say, customer or client for which you are developing this software. Such software are known as application software. The next set of software is engineering or scientific software. Now these are the software which are specific to engineering related technologies or scientific softwares. For example, the softwares that are produced in medical domain, or the software that are used in engineering, for example MATLAB or AutoCAD, right? So these are the software which are targeted for a particular engineering activity or some scientific research or scientific activity. That sort of software is known as engineering or scientific software. The next set of software is embedded software. Now what do you mean by embedded software? Now if you have a software that is part of an hardware, okay, so that is embedded into an hardware, that sort of software is known as embedded software. For example, you can take an example of microwave oven, right? So oven itself is an hardware, but you have a software which is embedded inside an oven. The dashboard of a car itself is a physical thing, it is a hardware, but you have a software which is embedded inside the car. The lift, you have a lift dashboard, lift itself is a hardware, but you have a software which is embedded inside the hardware. You have the dashboard from which you can control the software. Such softwares are known as embedded software. The next software category is product line software. It means there is a particular company dedicated to such software and they are producing the whole products, right? For example, Microsoft Word, right? So there is a whole lot of Microsoft Word, PowerPoint, Excel, etc. So these all are different products which are produced by Microsoft, and that category of software is known as product line software. The next software category is web application software. Now these web application software you can say that they are the subset of application software. They are type of application software, but application software is a combination of all the softwares, whether they are desktop software or web application software. Whereas web application software are particularly the software that run on web, that is www, right? For example, Twitter, LinkedIn, Facebook, Instagram, etc. So these are the web application software. And the last category of software is AI related software or artificial intelligence software. Now you know what do you mean by artificial intelligence. Artificial intelligence is a speed of computer engineering in which you make the machine work similar to the humans, right? So the mundane tasks of humans are actually incorporated in machine learning, and you are making the machine learn something, or you are training the machine so that they behave as humans. That field is known as artificial intelligence, and the software categories of artificial intelligence software you are using currently are Alexa, Siri, etc. Right. So these all are software application domains. Now the next thing is, what is the definition of software engineering? You know what is software, you know what is the difference between software and hardware, and you are aware about what are the different types or software application domains. Now what do you mean by software engineering? Because this is a subject that we are going to learn. Software engineering is application of systematic, disciplined, quantifiable. So there are three words that are attached to this definition. The first is systematic. It means you have to follow a system. There is a prescribed system, there is a prescribed process, there is a prescribed methodology which you have to follow if you are following software engineering to develop a software. The second is discipline. Now if you are following the system, it means by default you are following a disciplined approach. You cannot develop a software haphazardly without any thoughts and tell that you are following software engineering. If you are claiming that you are following software engineering methodologies, it should have a disciplined method. And the last is quantifiable. What do you mean by quantifiable? Quantifiable is basically related to quantity. It means whatever methodologies you are following in software engineering, that should be measurable. Now that can be an indirect measure, that can be a direct measure, that we will study in later on chapters, but all the things that you are following in software engineering must be quantifiable. So again, let us study the definition. Software engineering is systematic, disciplined and quantifiable approach to what? Now what are we applying this approach to? The first thing that we are applying the approach is to development. That is, you are applying this approach to the whole process, that is starting from the requirement analysis phase till the, you can say, testing phase. The whole process is known as development process. So you are following the system, you are following the discipline, you are applying the quantifiable approach to the whole development procedure. The second procedure or method is operation. It means when your software is completed and it is operational in the real world, then also you have to follow this approach, right? Once you have written the software, it is working, you have deployed it, your work is not done. When your software is operational in the real life world, still you have to follow the systematic software engineering methods. And the last thing in which you are applying this approach is maintenance. Okay, so there are some bugs that you may encounter even after deployment. There are some changes, there are some refinements, there are some upgrades that you will apply to your software even after delivering it to the customer, right? So this software engineering is a never-ending process. You can say that software engineering does not die. It dies when the software dies, right? So software engineering again is an application of systematic, disciplined and quantifiable approach to development, operation and maintenance of software. So basically, to sum up, it is an application of whole engineering to our software. Okay, now if you are using software engineering, software is evolved by past experience. And what are the factors that affect your software or software engineering? They are these three. The first is tools and techniques. It means what are the techniques that you are going to use while applying the software engineering, or what are the technologies that you are going to use. The next is methodologies. What is the method that you will apply for developing the software, for analyzing the software, for testing the software and for maintaining the software. And the last is guidelines. Now what are the guidelines, what are the standards, what are the procedures that you are following for development in your company. So these all are the things that should be quality things if you want to follow a software engineering methodology. Okay, the next thing is layered technology. Now software engineering is known as layered technology, and now we will study what are the different layers of software engineering. So here you can see there is a diagram in which clearly 4 layers are visible. We will study and we will discuss each layers in detail. you can say the base layer of software engineering is quality focus. Now, whenever you are talking about software engineering to be applied to any software, the sole purpose of applying software engineering is to provide quality software to the customer. So basically, you are defining continuous process improvement principle by applying all the software quality assurance methodology, like you can say capability maturity model, or you can say ISO 9000 standards, Six Sigma standards. So these all are the standards that you are applying in your software or in your company, and you are maintaining the quality. Also, you are trying to improve the quality, and that is the basic, you can say, base of software engineering, and that is the first layer of software engineering. The second is process. Now, process is nothing but, you can say, it is a combination of activity, actions and tasks, and it is basically a glue, or it is a foundation which holds together all the different layers. So it is defining the framework activities, that how will your software be accomplished. So all the activities that you are performing in a software, that comes inside your process. The next layer is methods. Now methods, it means you have different activities, you have different framework activities. For example, one of the framework activity is communication. Now communication activity, planning activity, all the activities and the prescribed methodology of that activity is a process. But how will you perform individual activity? That is, how will you perform communication? How will you perform testing? How will you perform designing? All the how-tos, the answer to all the how-tos is basically this layer, that is methods. What is the method you are going to follow for each of these activities? Right, that is the third layer of software engineering. And the last layer is tools. Now, tools can be the tools which are used for development, for testing, etc. Also in market there are automated tools, that is computer aided software engineering tools, also popularly known as case tools, which are automated tools which you can use in any, you can say, framework activities or the umbrella activities, which automates that particular activity and reduces your time. Okay, so it provides better quality, it provides quicker development, and if you are using these tools and methodology, it means you are following the software engineering standards. So that is the layer which you are going to see, that is the developers are going to see, right? So it is visible to the developer. So these are the four layers of software engineering. The first one is quality focus, the second one is process, the third one is method, and the fourth one is tools. Okay, now let us study generic process framework. Now what do you mean by process framework, or what do you mean by process? Now again, I told you in the previous slide, process is nothing but it is a combination of activity, action and task. Now what is the difference between activity, action and task? Activity is a broader perspective, or you can say it is defined by the whole framework activity. For example, you can say communication, right? So communication is a broader activity that takes place in development of software. Now what is an action? Now if you are in a particular activity, let's say if you are in a communication activity, there are different actions that you need to take place. Okay, that has to be done. For example, if you are performing communication, you must have to communicate with the stakeholder, right? So that is one of the action to be performed. So it is having a less broader aspect than activity, but there are predefined set of actions which has to be performed in a particular activity. Now you have activity, you have action, and then you have task. Now every action has predefined, or you can say you have a prescribed task set which you have to perform so that your action is completed. For example, if your action for the communication activity is to communicate with stakeholder. Now there are various ways in which you can communicate with stakeholder, right? You can have a phone call, you can have a Zoom meeting, you can have face-to-face conversion. So these are different task set that you can perform. You can communicate with the stakeholder using written communication like questionnaire, or you can have this face-to-face verbal communication. So what are you going to do for this particular action, that is communication with the stakeholder? All the tasks that are subset of action basically provides you the goal of that action, or you can say milestone of that particular action. So task set is having lesser broader perspective than the action, and action is having narrower, you can say, perspective than the activity. So task is a subset of action and action is a subset of activity, and the combination of action, activity and task is nothing but it is known as a process. Now if you are following the generic process framework in software engineering activity, you know that there will be different framework activities that you are dealing with. I told you communication, that is only one of the activity. There are majorly 5 activities that we will discuss later on, but there are 5 activities in any software development that you have to perform. So process framework consists of the framework activity. So here it is written framework activity #1. So it can be any framework activity. For example, the first activity is communication, right? Now in framework activity, I told you what you will have: action. So there are different actions that has to be performed for completing these particular activity. So here I have written action 1.1. So 1.1, it means that it is the first action of first activity, right? Now first action of first activity now further will have a subset of task set. It means for completing this particular action, I will have number of tasks that are to be accomplished, right? Now what are the task set actually consisting of? Task set will consist of milestones, right? So they will be intermediate milestones. Milestone, it means I have reached, you can say, a destination, and that destination, that intermediate destination or the combination of intermediate destination will actually give me one of the task, or you can say one of the action. The next is deliverable. For example, if you have a particular task, there should be some sort of deliverable, there should be some sort of work product that you are delivering to the customer, that you are delivering to some other stakeholder. And the last is SQA point. SQA stands for software quality assurance. Now whenever you are following a software process framework, you must apply the quality assurance activity, or you can say quality assurance methodology, in every task set that you are performing, so that it ensures that whatever process, whatever product you are going to make is a quality product, right? Which is the main goal of software engineering. So task set basically consists of all the tasks which ultimately leads you to the milestone. It has some sort of work product that can be delivered to the customer or any other stakeholder. Also it has software quality assurance points, in which the quality assurance teams ensures that whatever task we are performing is a quality task, right? So this was all about action 1.1. Similar to action 1.1, in activity 1 you have action 1.2, which further consists of another task set. So similar to this framework activity 1, for example, I have framework activity 1 as communication. In communication I have 2 different action, and in 2 different action I have different task set. Similar to communication, I have another activity that is known as designing. In designing also I have 2 actions, and in 2 actions I have different task set, right? So this is the general, you can say, process framework activities. Now apart from framework activity, in your generic process framework of software engineering, you have a second set of activity that is known as umbrella activities. Now umbrella activities are activities, as you can see, that they are running in background. Irrespective of any framework activity, you can apply these umbrella activity to every framework activity, right? So it is not dependent on framework activity, it is in background, it is running simultaneously to every framework activity in background. So it is like a shelter, like umbrella is, so the name is umbrella activity, right? So this is the generic process framework of software engineering, and this was all about today's lecture. Thank you.